Hi, everyone. Welcome to Math 70. This video is section 3.2, which is solving equations using substitution. So in the previous video, we solved equations using graphs, which are a type of pictures. So we over here with symbols and we use pictures to help us solve. Solving equations with substitution is about starting with symbols and staying in symbols. So graphing is a great way to do it. It's very efficient when working with two equations and two unknowns, but there are a couple of limitations, and one of those limitations is it only works when you have two equations, two unknowns. If you have more equations, graphing is going to be tough. And this method using substitution works for just about any system of equations, although we're going to focus on solving systems of two equations with two unknowns. So I'll use an example to get us started, and it'll be my example from the last video, x plus y equals 5 and x minus y equals 3. We already solved that using graphical methods and actually also using numerical methods by guessing and checking. But we're going to solve this using substitution. And there's a set of 5 steps that I want you to follow when solving an equation using substitution. The first is to look at your two equations and choose the equation that looks simpler. Any equation where an x or a y by itself is automatically going to be simpler, but even when you have two equations and two unknowns, you can look at this and say, one of these looks simpler than the other. In particular, that looks simpler if you were to solve for one variable. We've done this before. We've taken an equation and two variables and solved for one of those variables. Well, it takes a little bit of practice to kind of get intuition, but I'm going to tell you right now, I think x minus y equals 3 is going to be easier to solve for one of my variables, because all I have to do is add y to both sides and I'll have it solve for x. So once you choose that equation, solve it for the variable. Doesn't matter which variable, you get to choose whichever is easier. In this case, it's easiest if I add y to both sides and I get x equals y plus 3. I have now solved this equation for one variable, and I'm going to give it a star because this equation is something I'm going to use moving forward. Step 2, substitute the starred equation into the other equation in the system. And by other, I mean the one that I didn't already pick. So I picked x minus y equals 3. So I'm going to substitute the starred equation into the other equation in the system to get rid of one of the variables. As mathematicians, we look at a system of two equations and we're like, I don't like that this has two variables. So I'm going to change it so it just has one variable. That's going to make it easier for me. So we take my x plus y equals 5 and we rewrite it, but now we know that x equals y plus 3. So instead of writing x, I can write y plus 3. And then I finish the equation. x plus y equals 5 means y plus 3 plus y equals 5. This one happened to be pretty easy to substitute or to do those first steps. And once you've substituted, you're going to solve this new equation for the variable. Right, my new equation has only one variable in it. Y shows up more than once, but it's only a y. And I have the tools to solve that type of equation because that's what I've been practicing so far. Y plus 3 plus y equals 5. In this case, I can drop the parentheses and I just get y plus 3 plus y equals 5. Combine the like terms and I get 2y plus 3 equals 5. And now I'm rolling because I've solved these types of equations lots of times. I'm going to start by subtracting 3 from both sides to isolate the y. I get 2y equals 2. And then I'll divide both sides by 2 to get rid of the multiplication. And I have y equals 1. This is going to be one of my solutions. So the next step after finding one of your solutions is substitute the solution that you just found into the starred equation, because the starred equation will let me know what my other variable is. I had x equals y plus 3, but I know that y equals 1, so that must mean x equals 1 plus 3, so x equals 4. And there's my other solution. And the last thing you want to do is check the solutions in both original equations. Because you could have made a mathematical spelling error at one point, switched a plus to a minus, added something wrong, etc. And if you check your solutions in both of your original equations, you'll be able to find out if you've done it correctly. So I have x plus y equals 5 and x minus y equals 3. X is 4 and y is 1. 4 plus 1, yep, that's 5. And 4 minus 1, yes, that's 3. And that's how you solve an equation using substitution. I'll do another one. Maybe I'll do 2 more, just to give you a little bit more opportunity to see how it goes. So these are also going to be examples from the last video, which is a nice way to check because I know how to check them graphically. There's y equals -1/2 x plus 6. And 3x equals y plus 1. So the first thing I want to do is choose the equation that'll be easier to solve for one of the variables. I'm going to pick the top one because it's already solved for one of the variables. That's the easier equation. Then I solve it. Oh, sorry. So that's my easier equation. And I'm going to star it because I have solved one of my equations for one of the variables. The second step is to substitute the starred equation into the other equation, the one I didn't pick. So I have 3x equals, and now y is -1/2 x plus 6. And then a plus 1. Now I have an equation that has just a single unknown variable. The x shows up more than once, but it's only x's. And I'm going to solve this equation. In this case, I can just drop the parentheses. 3x equals -1/2 x plus 6 plus 1. 6 and 1 together give me 7. Add 1/2 x to both sides. That will get all my x's on the left side of the equation. And I get 3.5x equals 7, or if I did the fraction addition, it'd be 7/2 x equals 7. Either one is fine. Over here on the left, I divide both sides by 3.5, and I get x is 7 divided by 3.5, which my calculator tells me is 2. Or I could multiply both sides by the reciprocal fraction, and I also get that x equals 2. So there's the solution for one of my variables. Step 4 is to plug that solution in to my other equation. Oh, sorry, no. Plug that solution into my starred equation, because that's the simplest way to do it. Y equals -1/2, x is 2, and then we add 6. I'm going to do it here on one line so it fits. That is y equals -1 plus 6, so y equals 5. There's my second solution. Finally, I'm going to check both solutions in my original equation. So my original system of equations had y equals -1/2 x plus 6 and 3x equals y plus 1. If I check, I'm going to check that 5 equals -1/2 times 2 plus 6. Well, that's -1 plus 6, which is 5, so that works. And 3 times 2, does that equal 5 plus 1? Well, 3 times 2 is 6, and 5 plus 1 is 6, so that works also. If you're lucky enough that one of your equations is already written with y equals, or maybe x equals, that's going to become your start equation. You've already taken care of step 1. Okay, let's do another example. This system of equations is -2x minus 8y equals 8, and 8x plus 16y equals 80. I have to pick one of these equations that I think is going to be simpler than the other. To be honest, neither of them look very simple, but I think the top one might be a little bit easier. And in particular, I'm going to solve the top equation for x, because I think solving for x is going to be easier than solving for y. The first step is to solve my top equation for x. I'll add 8y to both sides. I get -2x equals 8y plus 8. Divide both sides by -2, and I get x equals -4y minus 4. So there's my start equation. I'm going to do step 2 here for more space. I'm going to substitute that start equation into my other equation. So -2, but x is now my other equation, 8, but x is now -4y minus 4, and then 16y equals 80. Now I have one equation, one unknown, but I need to simplify this a little bit so that I can solve it. So you can either see that as part of step 2 or part of step 3. So I'm going to solve this equation for y. There is a lot going on, but if I take it step by step, I should be okay. First, I'm going to distribute the 8 across the parentheses, and I get negative 32y minus 32, and then I still have the plus 16y equals 80. Combine the negative 32y and the 16y together gives me negative 16y minus 32 equals 80. Add 32 to both sides, and I get minus 16y equals 112. And divide both sides by negative 16. I get y equals negative 7. There's one of my solutions. And I'm going to go grab my starred equation to find my other solution. X should be negative 4 times negative 7 plus 4, which is, oh, this is a minus 4. Negative 4 times negative 7 minus 4, which is 20 minus 4, which is 24. So X equals 24 and Y equals negative 7. That's step 4. And step 5 is to check it in the original equation. So minus 2 times 24 minus 8 times negative 7 is negative 48 plus 56, which is 8, and it should be 8. That's good. And then 8 times 24 plus 16 times negative 7. I did the calculations earlier. It's 192 minus 112, which is 80, and that's also good. You can solve any system of two equations and two unknowns like this. The arithmetic can get a little more challenging, the algebra can get a little more challenging, but the steps are always the same. Now, just like with graphing, you might run into a case where you have either 0 solutions or infinite solutions. So I'll show you an example of what happens if you end up with 0 solutions. I use the example minus 10x plus 6y equals negative 30, and minus 5x plus 3y equals negative 12. So I have to pick an equation, and to me this looks a little bit easier because the 3y, I mean, none of them are going to be super nice, but this one is maybe a little bit easier. Minus 5x plus 3y equals negative 12. So I'll add 5x to both sides. And I get 3y equals 5x minus 12. And when I divide both sides by 3, I'm going to get y equals 5/3 x minus 4. So there's my start equation. Step 2 is to use that start equation in the other equation. So minus 10x plus 6, and y is now 5/3 x minus 4. And that should equal negative 30. And now I can solve this, or at least try to solve this. We'll see what happens for x. Minus 10x, the 6 times 5 over 3, that's actually 10x. 6 times 5/3 is 10. And 6 times negative 4 is negative 24. The minus 10x and the 10x cancel, and I'm left with the statement that negative 24 should equal negative 30. This is false. We arrive at a contradiction. There are no solutions to the system. there are plenty of x's and y's that make the top equation true or the bottom equation true, but there is no x and y that make both of them true at the same time. And let's look at what happens if we have infinite solutions, because that's also a possibility. So let's use as an example 10x plus 8y equals 40 and 15x plus 12y equals 60. Looks to me like this top equation is going to be a little bit simpler. So I'm going to solve 10x plus 8y equals 40. I could solve it for x or for y. I'll solve it for x this time. Subtract 8y from both sides, and you get 10x equals negative 8y plus 40. Divide both sides by 10, and you get x equals negative 8 over 10, which is the same as negative 4 over 5y, and then plus 4. And you could leave it as negative 8 over 10 if you wanted. It's still a fraction, and it means the same thing. Step 2 is to plug this into your other equation. So I have 15, but now my x I substitute with minus 4 over 5y plus 4. And then I have a plus 12y, and that should equal 60. And step 3 is to try and solve for y. So first I'm going to distribute the 15, and I get 15 times minus 4 over 5. You can double check, but that's negative 12. So I get negative 12y plus 60 plus 12y equals 60. And the negative 12y and the positive 12y cancel, and it leaves me with the equation 60 equals 60. And this is always true, no matter the XY pair. So if I can solve one of these equations, I am guaranteed to solve the other equation. Therefore, there are infinite solutions. It doesn't tell me what those solutions are. It doesn't mean any x and any y. The x and the y have to have this relationship in my start equation. Right? They have to be on the line of one of my equations. It just so happens that any point on this line is also a point on my second equation, this line. So there are infinite solutions. All right, that wraps up our video. Thanks for watching.